Hi all, good morning. Let's start Maths, Grade 11, Chapter 4. Chapter name is Complex Numbers and Quadratic Equations. Let us continue with exercise 4.1 from this left out problem from the previous session. Express each of the complex number given in the exercise 1 to 10 in the form of a plus ib. So in the previous video we completed till problem number 7. Let us solve problem number 8. Problem number 8 is 1 minus I whole power 4. Whenever there is a power 4, we can write it as square of square. So, here 1 minus I power 4, we can express it as 1 minus I square whole square. So, first we will simplify 1 minus I square. Then, again we will do the squaring of that one. So, now this is in the form of A minus B whole square. A minus B whole square formula is A square minus 2ab plus b squared. So here, as these are the complex number, we are denoting with a z. So z1 minus z2 whole square is equals to z1 square minus 2z1 z2 plus z2 square. Okay. Now let us replace z1 as a 1 and z2 as a I. We are going to get 1 square minus 2 into 1 into I plus I square. But what is I square value? I square is minus 1. 1 square is 1. So let us substitute in place of 1 square as a 1 and I square as a minus 1. Now we are going to get 1 minus 2I minus 1 whole square. So here minus 1 and plus 1 we can cancel it off. So therefore the left out term is minus 2I whole square. Again minus into minus plus 2 into 2, 4, I into I is I square. So, minus 2I whole square we can express it as minus 2I into minus 2I, that is 4I square. Again, we know that I square is minus 1. So, let us substitute in place of I square as a minus 1. Therefore, 4 into minus 1 is minus 4. Then, as there is no imaginary part, we can add it as a 0 times of I. So, therefore, minus 4 plus I0 is in the form of A plus IB, where A is equals to minus 4 and B is equal to 0. Let us go for this problem number 9. 1 divided by 3 plus 3I whole cube, we need to express it in the form of A plus IB. Here, we know that by observing this given number, we can write it as A plus B whole cube. In place of this complex number, we will replace this one as a z1 and this is a z2. So z1 plus z2 whole cube is equals to z1 cube plus 3z1 square to z2 plus 3z1 z2 square plus z2 whole cube. So in place of z1, let us write it as 1 by 3. In place of z2, let us keep it as 3i. Now we will write it as 1 by 3 whole cube plus 3 into 1 by 3 whole square into 3i plus 3 into 1 by 3 into 3i square plus 3i cube. Where here in place of z1 we are using this 1 by 3 and in place of z2 we are using this 3i. Now 3 and 3 are going to get cancelled here. Now we can write it as 1 by 27 because 3 3s are 9, 9 3s are 27. So 1 divided by 27 here. Okay. 3 into 3, 9i divided by 3 square is 9. So 9i divided by 9 plus 3i whole square is 9i square. 3i whole cube is 27i cube. Because 3 into 3, 9, 9 3s are 27. I into I square into I is I cube. Now let us cancel here 9 and 9. Now we are going to get 1 divided by 27, as we are cancelling here 9 and 9, so I you are getting I square we are replacing with this minus 1, I cube you can write it as I square into I square is minus 1, so minus 27I. Now let us separate the real parts and imaginary parts separately. So we can write it as 1 divided by 27 minus 9 plus I. When we are taking the I as a common here, there is a 1 is left out here. 1 minus 27. That is Now let us, for this real part, if we take the LCM here, we are going to get as 27 as LCM. So 1 minus 243, because 9 into 27 is 243, minus 26i, because 1 minus 27 is minus 26, minus 26i. Now let us again simplify this numerator. So we are going to get as minus 242 divided by 27 minus 26i. Therefore, the value we are getting is minus 242 divided by 27 minus 26i. This is in the form of a plus ib, where a is equals to minus 242 by 27 and b is equals to minus 26. Let us solve question number 10. We need to express this minus 2 minus 1 by 3 I whole cube in the form of a plus ib. Solution. We know that a, this is in the form of minus a minus b whole cube. Let us take minus 1 as a common. So we are writing it as minus 1 cube. Again 2 plus 1 by 3 I whole cube. Now minus 1 whole cube is nothing but minus 1 into minus 1 into minus 1, that is minus. Okay. 2 plus 1 by 3 I whole cube, we can write it as in the form of z1 plus z2 whole cube, use the formula, and we will write it as in place of z1 2 cube, in place of z2 we will use is 1 by 3i. So z1 cube means 2 cube plus 3 into 2 square into 1 by 3i plus 3 into 2 into 1 by 3i whole square plus 1 by 3i whole cube. Yeah, as minus 1 whole cube is minus 1, so we are keeping it as a minus as it is. Next step, we'll simplify now, and we are cancelling it here, 3 and 3. Then 2 square is, the second term is 4, we are getting. So minus of 8 into 4i, again here the third term we are cancelling 3 and then this one. So we are going to get as 2 by 3 I square, because this is 1 by 3 whole square. So 1 by 3, 1 3 you will get cancel it this here. The remaining 2 by 3 I square. Again 1 by 3 to I whole cube is equals to 1 by 27 I cube. Now in place of I square we will replace minus 1. In place of I cube we will replace minus I. As we know that I cube we can write it as is minus I. Now let us write here minus of 8 plus 4i minus 2 by 3 minus 1 by 27i. Again here let us take this real parts first, then imaginary parts. So what are the real parts here? 8 minus 2 by 3 plus I into 4 minus 1 by 27. For the real part, take LCM as is 3. For the imaginary part, this one LCM should be 27 here. So we are going to write it off, minus of 24 minus 2 divided by 3, because 3 4s are 8 3s are 24 minus 2 divided by 3. Again 4 minus 1 by 27, LCM is 27. So 4 into 27 is 108 minus 1 into I. Here this minus is there, we need to keep this one in mind. Again we will simplify it off. We are going to get as minus 22 by 3 minus of 107 divided by 27i, which is in the form of a plus ib, where a is equals to minus 22 by 3 and b is equals to minus 107 divided by 27. Let us solve question number 11. Solution. Here in this question what they are asking is, find the multiplicative inverse of each of the complex numbers given from 11 to 13. So here we need to find the multiplicative inverse. For example, any multiplicative inverse for the general normal number, for example, if I say this real number 2, the multiplicative inverse is 1 by 2. If it's a real number 3, 1 divided by. So when we are multiplying with this, that inverse, the product should be 1. In this case of the real numbers, now let us assume z as is 4 minus 3i. Here this is this real number case. Now if complex number we want to find it of this multiplicative inverse, we have to do it as is 1 divided by z. So let us see z is equals to 4 minus 3i. Now the multiplicative inverse of z is equals to z power minus 1, that is 1 divided by z, that is 1 divided by 4 minus 3. Whenever in the denominator this is imaginary number, let us rationalization of the denominator. So let us multiply this with this 4 plus 3i, both numerator and denominator. So the value will not change. So we are multiplying with this 4 plus 3i, both numerator and denominator. As the numerator is 1 into 4 plus 3, it will be as it is. The denominator is in the form of a minus b into a plus b. We know that a minus b into a plus b is a square minus b square. So let us use this. So the numerator is 4 plus 3i. The denominator is 4 square is 16 minus 9i square. Now in place of I square, let us substitute as minus 1, because we know I square is equals to minus 1. Therefore, 4 plus 3i to 16 minus 9 into minus 1. So this will become 4 plus 3i divided by 25. Now let us separate it as real parts and imaginary parts. So we are going to get as 4 divided by 25 plus 3i divided by 25. Therefore, the multiplicative inverse of 4 minus 3i is 4 by 25 plus 3i divided by 25. Let us solve question number 12. We need to find the multiplication inverse of root 5 plus 3i. We just now understood that how to find this multiplicative inverse. So let us assume z is root 5 plus 3i. Then multiplicative inverse of z is z power minus 1 or 1 by z. So multiplicative inverse of z is equals to z inverse, that is 1 divided by root 5 plus 3i. Let us rationalize this denominator. So let us multiply both numerator and denominator with this root 5 minus 3i. So we are going to multiply this numerator and denominator with the root 5 minus 3i. So here we are going to get as numerator root 5 minus 3i and the denominator is root 5 into root 5 is 5. 3 into 3 is 9, 9i square. So 5 minus of 9i square. So here I square is minus 1. So we are substituting this minus 1. Here again we can simplify this denominator. 9 minus of minus 9, 1 is here plus. So it will come as is 14. So we can write it as root 5 minus 3i divided by 14. That is root 5 divided by 14 minus of 3i divided by 14. Therefore, the multiplicative inverse of root 5 plus 3i is equals to root 5 divided by 14 minus 3i divided by 14. Let us solve 13th number. We need to find the multiplicative inverse of minus i. Solution. Let us assume z is minus i. Okay. Then the multiplicative inverse of z is z inverse. We can write it as z inverse as 1 divided by minus i. So let us multiply both numerator and denominator with I, because we should not keep this imaginary number value here in this denominator. So to get rid of that one, let us multiply with I. Upon multiplying with I, so numerator we are going to get as I and the denominator we are going to get it as minus I square. So I divided by minus I square. So in place of I square, let us replace with minus 1. So I divided by minus of minus 1, that is I divided by 1, that is nothing but I. So we can write it as this one as the real term is not there, we can write it as a 0 plus I. Therefore, the multiplicative inverse of minus I is 0 plus I. Let us solve 14th question. Express the following expression in the form of a plus ib. The given expression is 3 plus I root 5 into 3 minus I root 5 divided by root 3 plus root 2i minus of root 3 minus root 2i. Solution. Given expression is 3 plus I root 5 into 3 minus I root 5 root 3 plus root 2i minus root 3 minus of root 2i. By observing the numerator, we can easily say that this numerator is in the form of a plus b into a minus b. Therefore, this is as a plus b into a minus b, we can use the formula as a square minus b square. So 3 3 is 9 and minus of I square into 5 because root 5 into root 5 is 5. Similarly here, the denominator, let us simplify to minus. So we are going to get as root 3 plus root 2i minus root 3 plus root 2i. We can cancel it out here. Here this is this 9 minus 5i square divided by root 3 plus root 2i minus root 3 plus 2i. Here root 3 and minus root 3 we can cancel. So let us cancel plus root 3 and minus root 3. Then denominator is left out with 2 root 2i. Okay. So and let us replace the I square value in the numerator with this minus 1. Therefore, we are going to get as 9 minus 5 minus 1 divided by 2 root 2i. That is 14 divided by 2 root 2i. Again, let us rationalize this denominator. So, we are going to get as 14i into this. When you are multiplying with I, we are going to get as 14i divided by minus 2 root 2 because when we are multiplying here I and I, we are going to get is I square. So in place of I square, we are substituting minus 1, 14i by minus 2 root 2. Again we can cancel here. So we are going to get as 7 root 2 I divided by minus 2. Here that is nothing but minus 7 root 2 divided by 2. Now this we can express it as the form of 0 minus 7 root 2 I divided by 2 because as there are no real values are there, we are appending 0 to this value. Therefore, the simplest form of this given expression is 0 minus 7 root 2 I divided by 2. Thank you.